All right, this is going to be lesson 12.2. We're going to extenuation of trigonometry. First of all, there's two new phrases you'll see. One is angle of elevation and the other angle of depression. So angle of elevation, when you start at a level playing field and you look up, and that angle up, typically labeled theta, which you can't really see there. Here, let me do a better one. Theta. That's the angle of elevation. Angle of depression, when you start at a level playing field and you look down. And that angle going down here is the angle of depression, usually also labeled theta. You can kind of see here how you have the angle of depression, angle of elevation. So the angle of elevation from a sailboat at the top of a 121-foot lighthouse on the shore measures 16 degrees. How far is a sailboat from the lighthouse? So in this case, I'm going to use tangent of that angle because that's equal to the opposite leg. And this one would be the adjacent leg. So that's going to be 121 over d. Now why tangent? Because of SOHCAHTOA, where tangent is TOA, opposite leg over adjacent leg. Well, that's why I'm going to choose tangent, right? So we're not using the hypotenuse here. It's not in our ratio. So tangent is the ratio of those two sides of the triangle. And so I'm going to go ahead and multiply both sides by d. So d tan of 16 degrees is equal to 121. And divide both sides by tan 16, so that's 121 divided by the tangent of 16 degrees. And so when you multiply that out, you get d is equal to, does it say how to, doesn't say, so we'll just do 422 feet. Let's go ahead and approximately equal to 422 feet. And there you go. The next problem asks us to find A and B. And in this case, to find A, we're going to use cosine of 20 degrees equals the adjacent leg divided by the hypotenuse. We're looking at this angle here. This is the opposite leg. This is the adjacent leg. And this is the hypotenuse. And so, again, going back to SOHCAHTOA, the cosine is ca, that's the adjacent leg over the hypotenuse, so a over 11. And multiply both sides by 11, that's 11 cosine of 20 degrees equals a. And so when you get that, you get about 10.34 inches. It's approximately equal to a. And let's try to find b then. For b, I'm actually going to first find this length here. I'm going to call that x. And x is basically equal to b over 2, or half of b. And so to do that, let's see here. Let's go, this would be, let's do sine of 20 degrees equals x divided by 11. So 11 sine 20 equals x. And 11 sine 20 is 3.762. And then if we multiply that by 2, so b equals 2x equals 2 times 3.72. It's approximately equal to 7.5 inches. So that's going to be A, and that's going to be B. There we go. Okay, finally, Josh wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 35 degrees. How tall is the tree? Okay, so Josh wants to measure the height of the tree. He walks 100 feet from the base of the tree and looks up. So you have your tree, and you have Josh walks 100 feet from the base of the tree. So here's Josh. And the angle from the ground, so it's from the ground up to top of the tree, is 35 degrees. How tall is your tree? I'm going to call that length h. So this would be, what's the opposite leg? That's the adjacent leg. The other one's the hypotenuse. And so that's going to mean that tangent 35 degrees is equal to h over 100. And so 100 tan 35 degrees equals h, which means 70 feet. It's approximately equal to the height. There we go. All right, that concludes lesson 12.2.